we want to introduce the concept of average rate of change. And that terminology should be familiar to you. Average rate of change. That terminology should be familiar to you. So you should recognize rate of change means slope. Okay? So if I find the slope of a line, then that will tell me the average rate of change. So it's actually delta y over delta x, or y2 minus y1 over x2 minus x1, which you should recognize as the formula for slope. Okay, now what I have is I don't have a line. I have a parabola, and I'm trying to find the average rate of change between 2 points that are actually on the parabola. So how am I going to do that? If I draw a really rough sketch, okay, and I do mean rough, I have something that looks like that. That's supposed to be my parabola. This is at -6. This is at 0. I've got a vertex at -3, 9. And I'm looking for the average rate of change between the points at 7 and 8. Okay? The line that connects those 2 points will not hit the graph once, but it'll hit it twice. And because the arm of this parabola is so steep, our technology is going to make it look like this red line is lying right on top of that parabola. And that's not the case. It only shares 2 points. So what I would like to do is, if I find the slope of this red line, it will tell me the average rate of change between these 2 points on the parabola, because the 2 points are on the red line and the 2 points are on the parabola. Okay, so I'm going to use the information from the line, and I'm going to project it onto what the average rate of change is on the parabola. So if a line shares 2 points with a graph, we're going to call it a secant line. It's called secant. So hopefully you remember from geometry that if a line shares 1 point with the graph, it's called a tangent line. Well, we're going to find a line that shares 2 points with our graph, and we're going to find the average rate of change. So what I'm looking for is this parabola, and I want the average rate of change between 7 and 8. Well, looking again at my slope, I need to have 2 points that both have x's and y's. I only have x's. Well, I can go back up and I can find the corresponding y coordinates by evaluating these x values in my parabola. So to do 7, I'm going to do 7 squared plus 6 times 7. So that's going to give me 49 plus 42 is going to give me 91. So the point x1 is at 7, and it has a y1 of 91. So if I evaluate my function at 7, it gives me a y coordinate of 91. If I evaluate my function at an x value of 8, that means I'm going to have 8 squared plus 6 times 8. So 64 and 48 gives me 112. And now you have your x1, y1, x2, y2, and you can find the average rate of change over this interval on your parabola. So we're going to go ahead and finish this thing out. So my slope can be found using this formula of y2 minus y1 over x2 minus x1. My y2 is 112. My y1 is 91. And then x2 minus x1 is going to be 8 minus 7. So 112 minus 91 is going to give me 21 over 8 minus 7 is 1. So my average is algebra, AA. Average is algebra. My average rate of change can be found by finding the slope of the secant line, because those 2 points are both on the red line and on the parabola. So my average rate of change is going to be 21 units, whatever the scale is. So that is your problem of the week.